All right, guys. So today we are going to talk about a whole bunch of things angles. So first thing we're going to do is we are going to review some different ways to measure angles. So we know about degrees, but we're going to talk about radians again, something we talked about in Math 3, but we're going to review it again. So our definition here says radian measure of a center angle in a circle of radius r intercepts an arc length of length s. Then the angle radian measure is the arc length divided by the radius again. So really to get to this, we're just going to get down to some conversions, some nice pretty conversions, and it works from kind of extrapolating from this idea of arc length. So let's review arc length so we can use that in this formula so we can get our conversions, so we can go back and forth between radians and degrees relatively easily, okay? So we're going to write the formula for arc length in general. It says degrees in an arc divided by the degrees in a circle. So if we're using this our example here, first off the arc length, what we are trying to find right here is the length between x and y up here in the picture. That's our arc length, okay? So degrees, our central angle degrees for this is d. So our arc up here, this is going to be d degrees. And degrees in a circle, that's 360 degrees, so that's 360. And circumference of a circle, that's a defined formula. We know this is 2 pi times r. So what happens is we're finding the formula for arc length here. This is going to turn into, if we use our fraction rules, put this 2 pi r on top, we get d degrees times 2 pi r divided by 360 degrees. That is the formula right here. This is arc length. What I'm going to do is I'm going to put this up here, I'm going to put the radius in the bottom, I want to see what happens, and this is going to turn into a nice pretty set of conversion factors that'll take us from radians to degrees and back and forth. So here what this definition says is that radians, they were arc length divided by radius. So I'm going to put our formula for arc length on the top. D degrees times 2 pi r divided by 360 degrees, and we're going to divide all of that by the radius, which is r, from our picture up here. So to continue on with this, we're going to use fraction rules again to make this work. This has a 1 on the bottom of it, so this is really two fractions being divided. So we end up with d degrees times 2 pi r over 360 times 1 over r. And then we can go through and we can actually start canceling some stuff. We see this radius cancels out. Probably should have done this before, but 2 over 360, that's going to be a 1. That turns into 180. So what we find out here from this is that this idea of radians is actually equal to our degrees times pi divided by 180 degrees, which is actually there's another way we could write this. We could take the degrees, we can move them out. It actually means that if we look for this conversion for radians are actually pi over 180 times the degrees of that angle. So that gives us a nice pretty conversion. We take the degrees and multiply them by pi over 180, and that'll tell us the radians. And then conversely, we could take this and divide this to the other side, which means that this fraction would flip over. Now we could find out that to get the degrees, we could take 180 over pi times our radians. That would take us 2 degrees. So what we've seen right here, we actually, if we use this definition of what a radian is and what arc length is, we get these nice two pretty conversion factors to take us back and forth. These are things we practiced in Math 3 where we multiplied by these two fractions and converted from degrees to radians, and that's pretty much all we did with it in Math 3. And we're not going to do a ton more here, but we do need to understand how to go back and forth. So let's just kind of practice that. So now that we've got these formulas, If I have 15 degrees, how do I turn 15 degrees into radians? Well, which one of these do I want to use? So do I want to get degrees or do I want to get radians? I want to get radians, so I want radians to be by himself. So this is the one that I want. So for this table, I don't want that one yet. So to find the radian measure for this, this is going to equal, we're going to go pi over 180 degrees, and we're going to multiply it by our degrees. The degree measure is 15. Now there's a little trick that makes this a little bit easier. We got fractions again. Lots of fractions in this stuff. So let's make this a fraction and follow our fraction rules. We're going to get 15 pi over 180. These are both degrees. That's why the degrees will cancel out of this. And the only thing we need to do is we need to simplify this part of the fraction, 15 over 180. So if we go through and we pull up a calculator and we go 15 divided by 180, we hit enter, it's going to give us this decimal. But let's remember, we don't want decimals here. Radian measures are going to be fractions because we're going to have pi on the top of them. So hit math fraction, see what we get. We get 1/12. So that means that this is really 1 times pi over 12 as its radian measure. And notice the degrees canceled out of this thing as well. So we would just write this radian measure as pi over 12. What I'd like to do in this video real fast, pause me, because that's the greatest thing about having me on video is you don't have to listen to me constantly. You can pause me, try the next few. I'm going to go over and show you the answers in just a minute, but see if you can do them even just on your calculator and check your answers as we go. Okay, so go ahead and hit pause. All right, so you hit pause and you tried these, so let's go through and work these problems out. So same thing. We're always going to be putting this pi over 180, and it's going to be 45 degrees over that 1. So we get 45 pi over 180, and that's going to be 1 pi over 4. So this is pi over 4. Now I'm not going to write this out every time because I really think that you guys probably have this, but the only thing that changes about this setup as we go through and we look at this right here is that your degrees go up here, they end up in the top, and you just have to simplify that fraction. So with this one, we're going to get 90 over 180, which is 1/2. We get pi over 2. 120 over 180. That should give you 2/3 when you plug it through. That's going to be 2 pi over 3. This would be 135 pi over 180, which would give you 3 pi over 4. 165, so that 165 is going to end up on the top, and you've got to simplify that fraction, but that should be 11 pi over 12. And the last one, 180 over 180, that's going to give you pi, and that is our straight conversion factor. So a little bit of a trick as you work through there, if you can just kind of skip all this multiplication stuff and say that we understand what's going on here, we can end up here at this middle part every time to get those things to work. All right, let's look at this going the other way. So let's say that we had our radian measures here, and we want to go back to degrees. So we want to get degrees out of this thing. So this is the one we want this time, not this one, because we want degrees to be our answer. So we're going to say, well, this should be 180 degrees over pi. And we're going to multiply that by the radians. Now this is important while we leave this as a fraction, because what happens to that pi? We don't want pi in degrees. Pi goes away. That's also why it needs to be in the bottom. Pi will always be on the top of your radian measure. When we use the conversion factor, pi will be in the bottom here to make this thing cancel. So the only thing we have left over is 180 degrees divided by 6, which should give us 30 degrees. So just like last time, pause me, do the next 5. I'll write the answers in when we get back, and we'll make sure we're doing this good. So go ahead and pause. Okay, so you paused and you checked your work, hopefully. I'm going to write out the next ones. So let's see, we're going to still do the same way, 180 over pi. And we're going to run our radians here, pi over 3. That cancels, so we really end up with 180 divided by 3, and that's 60. One that you want to be careful with that you could easily make a mistake with is this 5 pi, sorry, let me start with my conversion factor like we did before. Is a 5 pi over 12, but we want to do 180 over pi first. We want 5 pi over 12. And the pi is still going to cancel, but we've got a number on the top here. We just got to be cautious when we go and plug this thing in the calculator, because we want 180 degrees times 5, and then we want to divide that by 12. So if we flip to our calculator, and let's actually plug that in, 180 times 5, and then divide that thing by 12, and we get 75, okay? So that's 75 degrees. Just be extraordinarily cautious, because this is one of those topics that's not too tough when you go through and you actually plug these things in, that you don't mess up with the calculator. So 180 over pi times 7 pi over 12. So here we're going to get 180 times 7 over 12. And let's actually plug that one in. So that's 180 times 7 divided by 12. That's 105. We get 105 degrees. I'm going to do the last one. We know pi is 180. That one's easy. You can do this with stuff over 180 degrees too. It would follow the same way. One more. 180 over pi times 5 pi over 6. That pi, just like it should appear, I just forgot to cross it out, ends up canceling. So we get 180 times 5 divided by 6. So let's go ahead and plug that through just to be safe. 180 times 5, then divide that thing by 6, and we get 150 degrees. So this is 150 degrees, and we converted everything. So 2 different ways to measure angles, radians and degrees. Degrees are what we're used to. Radians is just the measure of an arc length in what's called the unit circle, which we'll get into more later on in this section and in our e-learning in our unit, okay? So we're going to continue down our trek with angles, and we are going to talk about angles of rotation. And these are pretty much just what they sound like, angles of rotation. We're going to draw an angle and we're going to rotate it. So this says an angle of rotation is formed by the starting and end positions of a ray that rotates about its endpoint. So this says an angle is said to be in standard position at the coordinate plane when the starting position of a ray, called the initial side, is on the positive x-axis. So I'm going to draw that in here with my thing so we can see it actually happen. So this is the initial side. It's blue. And it is on the positive x-axis, and it has its endpoint, because rays only have one endpoint. Right there at the origin. That's where it's pinned down. You got to think of this like hands on a clock, okay? So when we have those hands on the clock, we're going to actually have to rotate this thing. So you got to think like you're going to put your finger on this, you're going to turn the hands of the clock. And we're going to rotate it counterclockwise. That's the positive direction. So I'm going to draw another line here. And it's just going to be where that thing stops. So to show the amount and direction of rotation, curved arrow is drawn to the end position. So let's say this is where this angle of rotation is going to stop. So we turn it all the way here. And this is called the terminal side, because terminal is where you stop. The angle of rotation is how far degrees or radians from where we turned. So it would be this arc right here, and we would label it with however many degrees this is, okay? So when we go this direction, that's positive. We turn this direction from the positive x-axis, that's going to be a negative angle of rotation, and we're going to do a couple here in just a minute. So let's practice one. Let's draw 300. So I'm going to draw my starting side, and I'm going to actually rotate it. Now, I'm at an advantage here doing this digitally because I can actually draw on the paper and rotate things. You could do this with your pencil if you needed some help with it. So we need 300 degrees. So a couple quick things. We're in the coordinate plane. So x and y axis, we know that all of these axes intersect at 90 degrees. They're perpendicular. So that means from here, if we started this and said this was 0 degrees, no rotation, up here would be 90 when we get to that side. Then there'd be another 90 in between here, which would get us to 180. Excuse me. Another 90 from 180 takes us to 270. And then all the way around, because we're going to give a circle in here, full rotation, 360 degrees, and then we can keep going. We just keep adding 90 every single time. So this one we want to get to 300. So 90, 180, 270. I know 300 is somewhere in here. Only thing I really want you to be cautious with when you go to do these, get them closer to where they're supposed to be. It should be closer to that negative y-axis. So it should stop somewhere right around in there. And then when you go to draw this, put a little dot on the x-axis. That's where we started. And we rotated that way. And then label it with how far it rotated. That was 300 degrees. Okay? So what I'd like you to do real fast, because you're going to pause me again. Go ahead and pause me. Sketch these out on a piece of scratch paper somewhere. And I'm going to come back and I'm going to draw these out for you and we'll check them. So go ahead and hit pause. I'll probably make a funny face. All right. So I think you hit pause and I hope you did these. Let's go ahead and let's try a few. So I'm going to put all of my starting position rays drawn up here first. We know that we're going to start on the positive x-axis. We always start on the positive x-axis with angles of rotation. And now we want to do negative 45. So we know that going this direction is positive, so therefore this direction has to be negative. That's going to work for each one of these rotations. So if this is 0, and we want to count out negatives, if we went downward, we went clockwise, that would make this negative 90 degrees. Keep going in the negative direction, you get another negative 180, a negative 270, and negative 360. So anything in a clockwise direction is considered a negative angle. So since we want negative 45, and 45 falls in between 0 and 90, and it's exactly halfway, we're going to draw this thing like that. And then the way that we would show that that's different than a positive angle is we would draw our little arc that said, hey, we started here on the positive x, and we went this way. Then we would label it with negative 45 degrees. All right, so 120, this is a positive angle, so we know we're going to be rotating counterclockwise. We know that's 90. 120 is only 30 more into this, so it's a little bit closer to the y than it should be to that negative x. Draw this arc. There it is. 450, that one's a little bit different because we know that we get to 90 here, 180 here, 270 down here because we're counting by 90. We started at 0, we get to 360. So where would the 450 degrees be? Well, 450 degrees would be continue past that 360. So if we take 360, we add another 90, we get to 450 up here, which is where we want to just stop. But let's kind of continue this pattern along. We added another 90 to that. What would we get to? We would get to 540. We'd add another 90 to 540. What do we get to? We get the pattern. We keep going around and around. We keep adding 90, right? This was 630. And then over here, we could hit again, and this would be 720. And we could keep doing this, how long? Forever. Over and over and over. We can keep spinning this circle around, or spinning around and this ray around in a circular fashion, and we would continue on. So even though the actual motion for this goes all the way around and then stops here, we just drew the line, all we would see is the line here on the positive y-axis. Now the way that we show that this is different than just a 90-degree rotation, we actually think like we have to show that we rotated it further. Okay, you see we got that full circle and then the 90. It's almost like there's a little pencil on the edge of that ray and it traces it out. That's where these arcs are coming from. And then we would label that thing with 450 degrees. All right, pi. So you do these things, you're gonna have to get answers in radians and in degrees, but my suggestion would be convert this to degrees because that's the way our brains are wired. We know pi is 180 degrees. So we know that this line should be over here and should have a arc this way, and just make sure you label it with the radians, even though we do our thinking in degrees, okay? All right, one more thing, and then we'll be done with this video. We'll move on. Coterminal angles, more things about angles. So coterminal angle, it's an angle of rotation in standard position. They'll have the same terminal side. So the first thing we need to do when we find coterminal angles, we need to draw this angle of rotation. So just what we just did, positive x, and we're going to draw this 45-degree angle, which is going to take us right in the middle right here. We're going to label this thing 45 degrees. Now what I want with this, I want to draw the picture once or twice, and I'm going to give you kind of a formula to help you with this later on. What I want is I want to know a negative angle and a positive angle that take me to the same spot. So if we drew this with arcs, if we looked at this, we could say, well, I don't have to stop when I first hit it. I could keep spinning and get to that side. That angle will be bigger than 360 degrees. I could also do the same thing, negative. I still start here on positive x, but instead of turning in the positive direction to get to this side, I can go negative and stop at that side. And both of these things are going to give me other angle measures that still take me to the same spot, but they have different angle measures as we go through. So, and they're all related to that 45. So let's look at this with a formula. I think we can see this with this picture of the bigger one. If we look at this, we see that, well, to get back to that side, I've got to do a full rotation and the angle that I wanted. So to do a positive coterminal angle, so let me get the right marker here. So to do a positive coterminal angle, what we do is we're going to take our angle of rotation, we're going to call that angle of rotation theta, and we're going to add 360 to it. To find the negative angle of negative coterminal, what we should actually see here, if we go and we highlight this, well, the red arc that I drew and the original one, those things add up to 360. So the way that I find that is, I take 360 degrees, I take theta and I minus 360 from it. Apologize, I'm having some writing issues here. So I'm going to take this theta and I'm going to minus 360 degrees from it. So to find the positive coterminal for this one, my theta is 45. So I'm going to go 45 plus 360. And sorry about the writing there, guys. But this is going to be, plug this in, 45 degrees plus 360, that is 405 degrees. Find our negative coterminal. We are going to take our 45, we're going to minus 360 degrees. So 45 minus 360. So that's going to give us a negative angle. It's going to be negative 315. So notice that our answers here. We got a positive angle for our positive coterminal. We got a negative angle for our negative coterminal. If we were ever asked to do this and we didn't get a negative number when we did the subtraction, we'd have to subtract again to find another negative until we get to a negative actual angle. Negative coterminal angles have to be negative numbers. Positive coterminal angles have to be positive coterminals. We can do the same thing with our radians here. My suggestion though, even if your answers need to be in radians, do this math in degrees. Pi over 2, and we're going to multiply that thing by its conversion factor so that we can get rid of that. So that means that angle in degrees, which is how we're used to thinking, is really 90 degrees. So I'm going to draw this one in here. 90 degrees is up here. We're going to do all the math just like we did on the other side in degrees, and then we'll just convert our answers. So I'm not going to draw the arcs or anything else, but we know that that's an angle of rotation of pi over 2. We get the idea of what we want to find. We want to turn negative to get there. We want to continue an extra 360-degree rotation to go through. So our positive coterm, that's going to be 90 plus 360, which is, what is 90 plus 360? It's 450. Our negative coterminal, that is going to be 90 minus 360, which is 270. Now, the only thing I'd want you to practice here is before you actually write your answers down here for these things, we need to convert them. So we need to take these things and actually convert them into radians, since we started in radians. If you ever start in radians, they're going to give you your answers in radians. So we need to remember our conversion factors. So we want to put pi back into this thing, so it's going to look like that for both of them. And pi on the top, 180 on the bottom. Remember, this is where we just need to do that division. So let's actually look at that. So 450 divided by 180. And we're going to math fraction that so we can get the fraction that we want out of it. So math fraction, that's 8/3. That's 8 pi over 3. That doesn't seem right. Let me see, did I hit a wrong button? I did. I hit 480. I apologize. Make sure you check what you're plugging in. So it's 2/5, 2.5. I apologize. And we hit math, fraction that. We're going to get 5 halves. So this is 5 pi over 2. And we're going to do the same thing here. 270 divided by 180. So 270 divided by 180. That's going to be 1.5, which should be 3 pi over 2, but it's going to be negative. I missed the negative when I wrote this thing here. So this is negative 3 pi over 2. And that's all there is to it for today. So just remember, I'll be online Monday, Tuesday, Thursday, Friday. Hit me up. Come see me. We can do any problems that you need help with. Okay, guys?